So before taking a look at this one, it's a good idea to take a look at the previous questions on Van Hoff factor and molality, because we're going to use both of those to solve this one. It says, what is the freezing point depression of a solution when 98.1 grams of iron 3 nitrate, and it gives a molar mass, is dissolved in 550 grams of water, and then it gives us the freezing point depression constant for water, and it asks us to assume the theoretical Van Hoff factor. So what we need to know is delta TF, the freezing point, equals I, the Van Hoff factor, times KF, the constant, times M, the molality. So the constant is the only thing that we already know. We need to figure out the Van Hoff factor I and the molality, the concentration M. It doesn't matter which order you do them in. I'm going to do the I first because it comes first. So we have FeNO3 solid. This is going to dissociate in water. And what you're going to end up with is Fe3 plus aqueous, okay, plus 3NO3 minus aqueous. So nitrate is a polyatomic ion with a minus charge. There are three of them. Since this has to be neutral, it means that Fe has to be 3 plus. All in all, we get 1, 2, 3, 4, because there's three of these, four ions in solution. So here, I is equal to 4. Now, we need to find the molality. Well, the molality is going to be the moles of solute divided by the kilograms of solution. So what we need to do is we need to go from grams of FeNO3 to moles of FeNO3 and we need to divide those moles by kilograms of solute, which is solvent, which is going to be water in kilograms. So starting with 98.1 grams of FeNO3 times, we're going to put 1 mole on the top, and the molar mass, 241.86 grams on the bottom. Now we want to divide this by the mass of the solvent in kilograms. So we're going to put a unitless 1 here. That moves the moles over so that we can divide. And then we'll have moles per kilogram. We need to put this in kilograms. So divide it by 1,000. Don't put in 550. Divide that by 1,000 and put 0.5500 kilograms. Sorry. And when you do that math, you're going to get that this is a 0.737 molal solution. You now have everything you need to know to find the freezing point depression. Delta TF equals I, which is 4, times the KF, which is 1.86 degrees C per molal, times the molality, 0.737 molal. And when you do that math, you find that the freezing point depression here is 5.48 degrees C. Note that the actual freezing point of water would be negative 5.48. We lowered the freezing point by 5.48 degrees C. It was 0 to begin with. We dropped it by 5.48 degrees, so the actual freezing point is negative 5.48 degrees C.